All right, now let's look at translating an English phrase to an algebraic expression. Now, getting good at this takes some time, and you typically see this kind of thing when you're doing word problems. When you're just doing like just a bunch of like math problems that aren't word problems, it's very clear what you're supposed to add, subtract, multiply, and divide from. Use order of operations. But word problems can sometimes use more creative language, and interpreting that creative language into a mathematical operation can be tricky sometimes. So, for example, you know, it would be nice if all word problems simply said to add two numbers, okay, a plus b. And so you'd write that a plus b. But another way of writing mathematically a plus b would be to say things like the sum of a and b, or you could say it a increased by b, um, or you could say b more than a, yeah, b more than a, or the total of a and b, or b added to a. All these different ways of saying simply a plus b. And likewise, we've got these other phrases for subtraction, for multiplication, for division, and for giving powers, or saying that two numbers or two expressions are equal to each other. Uh, there's a lot of different ways of even saying that. So let's kind of look at doing some examples to see what I mean. So here I've got just a snippet from a word problem where it says the difference of 14x and 9 in it. So when they say the difference of 14x and 9, what they really are saying mathematically is 14x minus 9. Okay, that's considered the difference of 14x minus 9. In the word problem, if it said the quotient of 8y squared and 3, what they really mean to say is that 8y squared is divided by 3. If they said 12 more than y, well, that's taking y and adding 12 to it. 7 less than 49 times x squared. So what's kind of strange is you sometimes have to reverse the order of what you read from left to right. So it says 7 less than 49 times x squared. So here we've got 49 times x squared, and then 7 less than that is minus 7. And here's another example, 8 times the sum of x and y. So what they're implying here is that first you do the sum of x and y. So here's the sum of x and y, and you put grouping symbols, parentheses around it, and then you multiply that sum by 8. So there we've got the 8. So this is really particularly tricky, and it just takes a lot of experience, a lot of practice to get good at interpreting what you read literally into translating that into a mathematical expression. So let's look at a few more examples here. Actually, these two, I want you to try on your own. Um, I would say pause the video now and try it, and I'll give you the answer. Okay, the answer should be 8x plus y. And the next one, pause the video. Okay, here's the example. And I think, or the answer, I think what I'll do is I'll try and write this one out. So we've got x cubed times, the sum of 2 times z squared and 15 times y. Okay, so here this sum of is talking about adding this 15 times y and this 2 times z squared. So we've got 2 times z squared, and because we're talking about a sum, we're talking about addition, and we've got 15y. And out here, we have x cubed times that sum. So here's the sum. And now we want to do x cubed times that. So that's how we would interpret or translate this literal description into a mathematical expression. All right, so we've just been focusing here on these examples with just little snippets, trying to understand little snippets. So let's progress to something a little bit more complicated, a little more complex. So here we've got an example. So translate from English to algebra. The length of a rectangle is 14 less than the width. Let W represent the width of the rectangle. Write an expression for the length of a rectangle. Okay, so this is just, what is this, a 3-sentence word problem. Okay, but already this may be difficult to understand and interpret. So let's try and break this down so that we can start working with the parts. So here we're being told we're going to let the variable W represent the width. Right? So in this first sentence, we actually have the relationship between length and width that we are being told we need to care about. And so width, we're going to be using the letter W. Now, we're not told anything about the length, so I'm just going to use the letter capital L to represent length. Okay, and we want to write an expression for the length of the rectangle. So, instead of expression, actually, this should have been equation because we're going to have an equal sign in here. Okay, so we need to write an equation for the length of the rectangle. So that's going to come out of this first sentence. So we have the length of a rectangle is 14 less than the width. So what I'm cluing in on here is the word is. The word is typically means equals. So what we've got is we've got this stuff on the left-hand side of the equal sign, and we've got this stuff on the right-hand side of the equal sign. So if we were to put our equal sign there, on the left-hand side, it says the length of the rectangle. Well, we're going to represent the length of the rectangle as L. And then on the right-hand side, 14 less than the width. So we could think of that as the width minus 14. And it says, write the equation for the length of the rectangle. Well, there we go. The length of the rectangle is the width minus 14. All right. So for this next one, try this one on your own. Pause it here, and I'll go ahead and write down the answer. So pause. Okay, you've tried it. So now let's check your answer. Should be D is equal to 4Q minus 7.